First function here given, f of x is natural log x, g of x, another parabola, x squared plus 4. So first question is to actually work out the function, so we can do that. We got f of g of x this time, so f of x is log e of x. So now we're going to do f of g of x, so it's f of x squared plus 4. It's going to be your natural log of x squared plus 4, replacing the x with this. Therefore, h of x is natural log of this x squared plus 4. So, looking at the domain and the range, best thing to do is sketch functions, look at the domain and range, and then we'll be able to do it. So, we'll sketch them first this time, and then we'll do these questions. So, f first, a logarithm, it's going to look like this. This is going to be f. Then g is going to be a parabola, so x squared plus 4, this is going to be 4 here, so now we can do a little domain and range table, see what we've got. So looking at the domain of f first of all, domain of f is just going to be 0 to infinity, which you could write as r plus, all the positive real numbers. G, parabola, no restrictions, going to be r. Looking at the range of both functions, the range of f is going to be all real numbers. And then the range of g is going to be starting at 4 including, and going up to infinity. So we're looking to investigate f of g of x here. So again, just going to look at what's happening here. So we're starting at x. The first function that you're performing has got to be the g part, to get g of x, and then you're performing the function f on g of x, so that's how you get f of g of x. Starting off here, just thinking about the first part of the function, not the composite, but you start off with the domain of g. Whenever you put in the domain of g, you get out the range of g or your answers. Looking at the second part, f, you're going to start with the domain of f. And then we're going to end up with a range of f of g, which is probably the hardest thing to work out. But we'll show you a way of doing that using the graphs. Okay, so this is the important thing here. So the domain of g, see, is going to be r. The range of g we got was 4 to infinity. And the domain of f was 0 to infinity. So if we're looking to understand why this function does exist, then you'll see here, if you're looking at the values that you're getting out from the first part of the function g, 4 to infinity, are there any values within that that are not going to fit into this part, that are going to stop the f part of the composite function working? And the answer is no. Okay, so because of that, we can say that because the range of g is a subset of the domain of f, all the values in the range of g lie within the domain of f, then the function is going to exist. So because it does exist, we can say that the domain of h of x is going to equal the domain of, starting off here you see g of x. So in this case, the domain of the composite function is going to be r. Looking at the range, it's going to be a little bit different. Again, we're getting values out here, the range of 4 to infinity. So they're the only values that you're using for the second part of the composite function, you see. So what happens is, this is no longer your domain. Some of these values are not relevant. You can't get 0, 1, 2, 3. So that means that your function, this part f of the function, the domain is going to change to 4 to infinity. So we want to look at f here, and then look here, and this is the way we're going to get the range. So here, this coordinate here is going to be 4, and then it's only going to exist from 4 to infinity. We can't have this section of the f anymore because you're not getting values, you're not getting 1, 2, 3. You're not getting those values there, so therefore that's the only part that it is going to exist for. So substituting this into f, this is going to be natural log of 4. So you see there, we can tell what our range is going to be then. So the first value we're going to hit is natural log of 4, and it's going to go up to infinity. So therefore, your range of h of x is going to be ln 4, which stands for log base e, of course. And then it's going to be going up to infinity. So I don't know why I put a curved bracket there, because it is going to include. I was thinking it was a coordinate. And that'll be your range. So again, let's flick on the CAS and make sure it all makes sense. So if we define the functions, first of all, we got f of x. So let's see this. F of x is natural log of x. That is ln of x, and then g of x was x squared plus 4. Okay, and then what we did is we did h of x was f of g of x. So let's just sort of define that. F of g of x, that gives me that. So let's just check our first answer. So that's all good, that's right. And then let's see what the domain is going to be. So here, the domain of h of x, comma x. So that was all real, so that's good. So let's sketch this function, see what it looks like. So we got h of x, looks like this. So again here, this is going to be the minimum here. Okay, so if we go back and just get f min, it's going to go up to infinity. So let's do f min of h of x, comma x equals 0. Predicted h of 0 is 2 ln 2, which we wrote it as ln 4, which obviously if you just take the 2 up there, then it's ln 4, and then it's going to infinity, so that's all good.